Hey there, it's Jason from Codemanship with another video diary entry. If you're enjoying these videos, please like and subscribe and ring the bell for notifications for new content. Okay, before we start, a shameless plug. The onboarding season is upon us. Many fresh graduates, freshly minted computing graduates joining companies. If you've got new hires starting at the moment or at any time in the future, of course, we're always open for business. Then drop us a line and we can hopefully fill in the gaps in the practical side of their education in codecraft, TDD, unit testing, refactoring, continuous integration, design principles, and all that wonderful stuff that they often don't teach in university in a practical way. Okay, so that's the shameless plug out of the way. Let's talk about what we want to talk about today. So something that comes up very often, let me just launch this little presentation. Something that comes up very often when I'm teaching TDD or mentoring developers in TDD is the level at which we should be targeting our tests, or more bluntly, what our tests should be about. And when people are new to TDD in particular, I see something going wrong that can lead them into deep water. And to illustrate that, I've taken the example of a CD warehouse, an online shop that sells CDs, old school, no downloads here. We've been asked to implement some features for buying CDs, for checking the stock of CDs, and for receiving batches of CDs, deliveries from record labels into the warehouse. And like good software developers, we had a little think about the design. No one is ever going to tell you not to have a little think about the design. And we did a little sketch. We've got a little class diagram that we think will fulfill those particular use cases. So we've got a warehouse that has a catalog. You can check the stock in the warehouse. The warehouse receives stock, and we can buy CDs through the warehouse. So that's kind of the entry point to our logic there. The warehouse has a catalog of CDs that we can search, and we can add stock to that catalog when we receive them from the labels, when we receive deliveries. And we also have an interface there for processing payments with some kind of external payment provider. So we think that will satisfy our design. Now, here's where we go wrong. This is what I see a lot of developers doing. They look at their little class diagram there. Maybe it's in their head, maybe it's not on paper or in PowerPoint, my favorite modeling tool. And they go, right, a warehouse has a catalog. Right, warehouse has a catalog. Let's write a test for that. So I see developers doing things like this. Oops, too many brackets there. It's been a while since I've done any C#, by the way, so please bear with me. Let's create that local variable there. I'm going to press escape and not enter because I know what you're going to do. And there we go. Let's create that class. That's the thing that we're testing. Or are we testing it? Let's create a new instance of it. And now let's create this catalog property. We'll make it read only. Okay, let's create that class. So that's kind of my failing test there. The warehouse has a catalog. At the moment, it does not have a catalog. The catalog is null. So I'm doing TDD. If you watch my courses online about TDD, I wrote a test first. I wrote the assertion first and worked backwards to the setup. I'm running the test to make sure that the test assertion does indeed fail. So I know it's a good test going forward, that it's going to protect us if we break this code. And now I'm going to do the simplest thing I can think of to get this test to pass. Well, maybe not the simplest thing, but the most obvious thing. So let's start by backing it with a field. Or no, let's initialize it from the constructor. Oh, that's interesting. We can do it there if we want. Let's go back to our test. Not so smart, are you, Ryder? Okay, there we go. That little bit of cheating there, but that should pass our test. The simplest thing we can do. Let's give it a new catalog. Okay, we've got a passing test. And then we might start to work our way around the design and say, okay, what happens when we buy a CD and we have to find the CD in the catalog. So we might write a test for finding a CD and adding a CD and so on and so forth. So we're working our way around the internal features of a design, implementing all of the features that we think we need in order to pass that test. And the big disadvantage, well, there's two big disadvantages of working this way. The biggest disadvantage is there's a danger here, but why does the warehouse have a catalog? What does that give to our end users? Did the users say to us, oh, we want a warehouse to have a catalog? Or did they say, we want to be able to buy CDs from the warehouse? Or we want to be able to check the stock of CDs in the warehouse, and so on and so forth. So we're not working at the level of end users and what they want, what their goals are. So one danger is we end up not satisfying those goals because we're focused on the internal features of a design rather than satisfying end user goals. The other big drawback is we tend to end up with lots and lots of very low level tests. So we end up with a lot of test code, and also our tests are now sticking to the internal design, like sort of melting cheese into a radio. It makes it very hard to maintain the radio when you've melted cheese inside it. Our tests are sticking very closely, like glue, basically, to the internal design, to the features of the internal design. How do we know we need these features? Let's flip our thinking around and let's be test driven. The clue is in the name. So rather than, like I said, it is good to think about design, but maybe rather than starting here with, say, a class diagram or sequence diagram or something like that, or even doing it in our head, which is what most developers do these days, maybe instead we just think about what do the end users want? Who's using this? What do they want? We start there with use cases or user stories, things the user wants to be able to do. So a customer wants to buy a CD or check the stock of a CD. Maybe the warehouse want to do that as well. And the record label wants to be able to send us more CDs so we can sell them for them. So starting there with buying a CD, we might sit down and think, well, what are the test cases we need to handle here? So this would normally be a conversation with our customer. Well, there's the happy path when we've got sufficient stock of that CD and the customer's credit card payment is accepted. But also, what happens if there's not sufficient stock? What happens if their card payment is rejected? So we're thinking a bit like testers now. But these are all expressed at the level of end users and what they want the system to do, or rather what they want from the system. So we can drive it from this way round. And that gives us a very different focus. So rather than writing a test, let's delete the body of our test there. Rather than writing a test that says the warehouse has a catalog, let's get rid of our speculatively implementation there. We make our test around one of the outcomes of one of these scenarios. For example, what happens to the stock of a CD after we've bought it? So buying CD reduces stock by sale quantity. Okay, so we're now looking at it in terms of outcomes, user outcomes. What does the user want? So we're going to write a different kind of a test now. Let's say we had a stock of 10 to begin with. That's our example, and we buy one of those. We should end up with a stock of 9. Okay, let's create our CD variable there. Let's declare that class. Okay. And let's instantiate it with a stock of 10. Okay. Let's create a read-only property for stock. Let's make that an int. Good guess, rider but no cigar, close but no cigar. Okay, let's give it a constructor. Okay, now in our original design, I assigned the buy responsibility to the warehouse class. And that means we have to involve the warehouse, and also we have to search the catalog for the CD that we're talking about by artist and title. I actually think I can come up with a much simpler design. If we already know which CD we're talking about, why not just go direct to the object, cut out the middlemen, and say, well, why don't we just say, okay, CD.buy. So we're going to buy one of those CDs, okay, and Let's create that method for buying the CD. So we'll say that's the quantity for now. And we'll get to payments in another test. Okay, but there is our new test. Let's run that test and see it fail. So it's exactly the same technique as before. Test first, assert first, work backwards, see the test fail, do the simplest thing to make the test pass. But we've come up with a much simpler design because our focus was not on the design, it was on the end user and what they want. I call these meaningful tests. These are tests that are about things that mean something to the end user, that mean something to our customer. So let's make this pass. Okay, I think we're going to need to assign that. It's got no suggestions here. Let's see what you said. It's not suggesting anything. It's locked down in a mode here. Okay. Initialize the auto property stock. So far, so good. And when we buy, we want to actually just deduct the quantity. An obvious implementation, really. And that means we need to add a setter, but we don't want that to be visible. So let's make that private. Okay. And that should make our test pass. Superb. Let's just push on and do one more test. So there are a couple of outcomes we're interested in. One is what happens to the stock of the CD. Maybe the other outcome is how much is the customer's card charged. So let's write a test for that. Card is charged for CD price times sale quantity. Okay, and a similar kind of thing, but this time we don't really want to worry at this point about how we're processing payments. We just want to know that the right amount was paid. So let's imagine we have something that accepts payments, that processes payments. We're going to verify. In fact, we probably need to work backwards from here. So card.verify. And I'm trying to remember the syntax for this. Amount. Can't remember. Oh, no. It's I'm just going to pause this. I haven't used mock in a while. I'm just going to pause this and look it up. No shame in Googling. Okay, sorry about that. I think I've got it now. So let's call that our mock. Verify card.pay, and we're saying the amount should be. So if the price of the CD is £10 and the quantity is 2, then the amount should be 20. Okay, now let's work backwards from here. So that can be a var, and we're going to use Mockito to mock it. We imagine there is a credit card. Just import that. Okay, we need to define that. So we're going to create a type for credit card, but we're going to make that an interface. Doesn't need to be real yet. Pay method, oh yeah, it's C#, so we'd better use a capital P. Okay, let's create that method for pay. So we're working backwards. The amount, how much are we paying? Okay, and now we need a similar setup to before. So let's give it enough stock there. And we want to buy that CD. We're going to buy 2, but now we also need to provide credit card. So we're going to change the signature of buy to also pass in our card, our mock object there. So let's add the parameter credit card. Just to see, that will have broken our first test, but that's fine. So let's call that card. And back. So we will also have to change our first test. In order for this to work, it can't be null. So let's insert a mock credit card and give it the object so that it's not null. Basically a dummy is the correct phraseology for that, correct term. Okay, so we've got a test here. Let's run both of the tests actually, just make sure the first one still passes. Okay, it's only running the one test. Can you run both tests for me, please? Thank you. It was just taking a little while there. So we're getting an expected invocation is not happening. So let's make that happen. Again, obvious implementation. Pay quantity times. Okay, we're going to have to imagine that there's a price. So we need to provide some more information here. Let's try get only property price. And that means that we're going to have to also provide a price. Let's do it by changing the signature of the constructor. Can't remember what the shortcut is for finding your refactoring menu in Rider. Like I said, it's been a while. Okay, let's do change signature, Control RS, that's it. So we'll add, let's make that a double. That's our price. Okay. And use the following value. So we're going to give it a price of 10 in both of those tests. Okay, let's assign that to our doesn't want to assign that to price. It's interesting. Should we try again? Manually. That's why. Again, it took a guess and it guessed wrong. Should have noticed that. Okay. And we don't need to change the price at any point, so that should work. And there we go. So we've implemented the functionality to pass that. So let's cross that off our list. And then we can move on to the next scenario. The next scenario, so working sort of one user story at a time, working one scenario at a time and one outcome at a time. We test drive the simplest design that will satisfy those scenarios and those meaningful tests from our customers. Now, this can be contentious for a number of reasons. First of all, when I suggest to developers, your test should be at this level, they've got a kind of an internal barrier, a mental barrier here, that no, these aren't unit tests, Jason. These are functional tests. These aren't unit tests. And then they have got another mental barrier that functional tests need to be tested through the UI or through the API. Now, that simply isn't the case. As you can see, we can test what happens to the stock of a CD when you buy it without having to go through the UI. And if you do go through the UI, it's kind of at the other extreme. The other extreme thing that happens is people do write their tests at this level, but they also test it too high a level in the application, at the system level, for example. So they end up with test suites that run slow, which is bad. But they also they end up in a situation where there is a tendency for the logic to kind of bunch up at the entry point where we tested it. I suppose it's a similar effect in some ways to, when you're at a rail station and people are sort of flooding out onto the platform from an entrance or from a staircase. And there is a tendency, they don't spread along the length of the platform necessarily. There's a tendency for most of them to kind of bunch up and congregate around the entrance. And code can be a bit like that. The entry point for your tests is often where a lot of the code tends to bunch up. So developers who are doing most of their testing at a very high level, e.g. through the UI or through an API, they tend to end up with most of their logic being in the UI or around the API and not pushed down. So for all those reasons, I think it is better to write tests that are about these things, but that are targeted at the internal design, at the right level, at the object about which the test is or is going to become about that. And then you end up with tests that, number one, are about end user outcomes. Number two, they know less about the design, but they are still internal tests. They are still unit tests in that respect. I have absolutely no problem with a test involving multiple objects, for example, or multiple classes. Our goal, remember, is not to test all the features of the internal design. Our goal is not to test all of this. Our goal is to satisfy these, to give our end users what they want. So that's what your test should be about. Like I said, meaningful tests. Okay, so that's something that goes wrong with test-driven development, this idea of, I call it test-driven design. It's putting the cart before the horse, in the sense that your tests are really about the design and not about the end user and what they want. And the idea is that we're supposed to be discovering the design through writing and passing the tests, and also through refactoring afterwards. So we discover an internal design. If we follow the rules of TDD, every line of code in our internal design will be tested, because we won't have written a line of code unless we needed it to pass a test. But there won't be a test for every method of every class. There won't be tests for constructors and getters and setters and stuff like that, because constructors and getters and setters and internal classes and that kind of thing, these are consequences of passing these tests. They're consequences, they're not the point of it. Okay, so I hope that's been of some help or cleared up some misunderstandings. Like I said, for some people, some of this is contentious. I had an American chap walk out of a training course. It's only happened once in 12 years. But he left the training course and asked for a refund because we had this very argument. He had been taught by his, his masters, as it were. He had been taught that you're supposed to write tests for everything, for every public method and for every getter and setter. And I was trying to persuade him of the folly of that. I failed in that respect. So he became a bit sulky and disruptive. And I felt it was unfair on his pairing partners in the course. So we had a little conversation and we agreed to disagree. And he enjoyed the rest of his stay in England, I hope, in London. But I don't think he got a lot out of the training. And I could bet good money that he still thinks you need to write unit tests for everything. So there you go. That's what test-driven means. That's what it means. The clue is in the name. Hope you're staying safe until the next video diary.